Hi guys, welcome back to your physics lessons. I'm Asad, your physics teacher. Today I'm gonna teach you the new title of physics. That title is Lens Maker's Equation. In previous video I told you about power of a lens. Power of a lens depends on focal length of a lens. Now what is lens maker's equation? The focal length of a thin lens depends on the radii of its front and back surface, and also the index of refraction rate of the lens material. Focal length, power of a lens depends on focal length. Focal length of a lens depends on the radii of its front and back surface, and also depend on index refraction of lens material. The equation that interrelates these quantities, which quantities? Radii of its front and back and index refraction is called the lens maker equation. This is the lens maker equation. C is equal to 1 over F. C means power of a lens, convergence of a lens, is equal to N minus 1, 1 over R1 minus 1 over R2. This equation says that focal length or power of a lens depends on two things: index refraction of lens, radii of surfaces, R1 and R2. What is R1 and R2? R1 and R2 is the radius of the surfaces, radius of front and back surfaces. When R1 and R2 is positive, R1 and R2, remember this line, R1 and R2 are positive if the center of curvature for each surface is behind the lens. And when R1 and R2 is negative, if the center of curvature for each surface in front of the surface. What is in front and back behind the surface lens? I told you before. Incident ray, when the ray parallel to principal axis, it is refracted and pass through the focal length. This is refracted ray. This side is called front side of the lens, and refracted rays you see, this side of the lens is called back side of the lens. And R1, it is R2, and it is R1. You see in the figure. When our R1 and R2 is positive, if the center of curvature for each surface is behind the lens. When R1 and R2 is negative, if the center of curvature for each surface is in front of the lens. Remember these 2 points for lens maker equation. When R1 and R2 is positive, when R1 and R2 is negative. Remember those points that I taught for you. And now let's solve question about lens maker equation. Find the focal length of the lens shown in below figure. You see, this is a lens. This is plano-convex. This is a plano-convex. Now we find focal length. Here, R1, we should find R1. R1 is, you see in this view, R1 is here, R1 is plan. Plan is a surface that the radius of that surface is infinity. Plan is a surface that its radius is what? Infinity. R1 is what? Infinity. What is R2? R2 is 10 centimeter. R2 should be what? Negative minus 10 centimeter. Why? Because it is in front. It is in front of side of the lens. R1, R2 should be minus and be why? Because it's in front of the what? In front of the lens. R2 is minus 10 centimeter. What is N? N is what? 1.5. It is glass. You know that lens is glass. The index refraction for glass is 1.5. Find focal length for, we have a lens maker equations. This is a formula. This is lens maker equation. From this formula we can solve that questions. Now 1 over f is equal to n minus 1, 1 over r1 minus 1 over r2. 1 over f, what is n? 1.5 minus 1. 1 over r1, what is r1? 1 over infinity minus 1 over, what is r2? Minus 10. You know that minus divided by minus will become positive. 1 over f is equal 1.5 minus 1 is equal to 0.5. 1 over infinity is 0. 0. Okay, minus divided by minus become positive. 1 over 10. 1 over f is equal, we write like this, 0.5 is equal to 1 over 2 times 1 over 10. 1 times 1 is equal to 1. 1 over f, 1. 2 times 10 is 20. We multiply this one. 1 times f times 1 is f. 20 times 1 is 20. 20 centimeter. We found that the focal length of this plano-convex lens is 20 centimeter. Now, example number 2. Find the focal length of the lens shown in below figure. Here we have, you know that here we have what? Concavo-convex. This is a concavo-convex mirror lens. Sorry. We found what? Focal length. First, you know that it is C1, it is R1, it is C2, it is R2. And also you know that N is what? N is 1.5. Now we find focal length. What is the formula for finding focal length? Here we have this formula. This formula is lens maker equation. 1 over f. 1 over f is equal to n minus 1. 1 over r1 minus 1 over r2. 1 over f is equal, what is n? 1.5 minus 1. 1 over, what is r1? R1 6 centimeter. R1 6 centimeter, but it should be minus 6 centimeter. Why? Because I told for you, R1 and R2 is in negative if the center of curvature for each surface is in front of. You see, R1 is in front of the lens. It should be what? Negative. I put here minus 6. Okay. Minus what? R2. R2 also should be what? R2 also should be minus. Why? Because it is in front of the lens. Minus 1 over minus what? 3. 1 over f is equal 1.5 minus 1 is equal to 0.5. And also here we have 1 minus 1 over 6. Okay, 0 divided by, minus divided by minus, it has become positive. Positive 1 over 3. And 1 over f is equal to Here we have 1 over 2. We can write. It is 5 over 10 is equal to 1 over 2. And what is the LCM of these two numbers? Is 6. 6 divided by 6 is 1. 1 times 1 is minus 1. Plus 6 divided by 3, 2. 2 times 1 is 2. 1 over f is equal to 1 over 2 minus 1 plus 2 is equal to 1 over 6. 1 over f is equal. We simplify this. 1 times 1 is equal to 1. And 2 times 6 is 12. Now we multiply this. F times 1 is f. 12 times 1 is 12. 12 centimeter. We found the focal length of this lens is 12 centimeter. These are all about lens maker equations. My students, if you have any question about lens maker equation, try to comment below. And also if you want to learn physics, try to follow our YouTube channel. Have a nice day. Goodbye.